Hello, good evening. So today we'll be treating cycle geometry 1. So in our next video, we'll be treating cycle geometry what 2. So what we're going to be doing today is just what the formulas or what the explanation towards cycle geometry. That's for all the theorems applicable towards cycle geometry 1. So the first theorem is what? A straight line drawn from the center of a cycle to bisect a chord, which is not a diameter, is at a right angle to the chord. So when you're having this particular number 1, when we are having a particular cycle, what's the chord? Any line being drawn from any two sides in a cycle and it's a single line, that particular line is called what we call. For example, this is the center and you draw a line this particular way. This particular line is simply what a chord. So if there's any particular line you draw from the center of that particular cycle to the chord, to the middle of that particular chord, must be at the right angle to the chord. That's what the first theorem is trying to say. So in that particular case, that simply means this particular side is the radius. This side is the radius, which is r. So from that particular concept, we can always divide the chord into two places and find distance from the center of the cycle to the chord. So we can apply Pythagoras in this particular triangle as always to look for any side that you want to get. So that's the first theorem. The second theorem states the angle that an arc of a cycle subtends at the center is twice that which is subtends at any point in the remaining part of the circumference. So number 2 states, very simple, when you have a cycle this way, and this is the center. Let's say this particular center makes an angle. This is the angle of the center. Then it's now particular angle. This is a particular chord. This chord makes an angle at circumference, and this same chord makes an angle at the center. So the concept is trying to say that the angle being made at the center is twice the angle being made at the circumference by same segment or same chord. That's the concept to that. That simply means if here is x, that means this particular center is going to watch 2x. That's the concept about that particular theorem. The third theorem states angle in same segment of a cycle are equal. Number 3, angle in same segment of a cycle are equal. So we have this. Let's say you're not having a particular segment. Let's say this is a particular chord or a particular segment. Angle being made by this particular same chord or same segment are always equal. That means all these particular angles are equal. When you have another angle this way, you can have another angle this way. Angle being formed by this particular same segment are equal. That means if here is x, let's say here is x, let's say here is y, and here is what z. From that particular word third rule, that simply means x is equals to y and is equals to what z. This is the rule for that particular word theorem 3. Therefore, theorem 4, the angle in a semicircle is a right angle. What is a right angle? The angle in a semicircle is simply what a right angle. So number 4 simply states when you are having a cycle this way, the angle being formed by the word semicircle, this is center. That means you'll be having a diameter passing to that particular center. So the angle being formed by this particular word semicircle is going to be what a right angle. That simply means the angle being formed is simply what 90 degrees. Take note, it can be at any point, but the angle being formed is going to be 90 degrees. This particular law is still in line with this law. Because if you notice, if here is 90 degrees, that simply means 90 times 2 is going to give us 180 at the center. That simply means if the line at the center is straight, diameter, you have a diameter at the center, that simply means the angle that will be formed at the circumference is going to be 90 degrees. So I'm doing my best to meet up with time. Don't want to exceed. So this is the third law. The last one but not the least, which is what number 5, is simply that the opposite angles of a cyclic quadrilateral are supplementary. That simply means taking of cyclic quadrilateral. A cyclic quadrilateral is any quadrilateral, any shape of four-sided that all the vertices are touching the cycle. For example, you can have something like this: 1, 2, 3, and 4. So in this case, this particular side is x, this particular side is what y. These are opposite angles. Let's say here be A and let's here be what B. When you something is what supplementary in mathematics, that simply means it's adding up to 180. So from that particular law, that simply means x plus y is simply equals to 180 degrees. At the same time, A plus B, because they are facing, x and y are facing, that's 180 degrees, and A plus B are also facing each other, giving us 180 degrees. So these are the basic laws of what cycle geometry from 1 to 5. So the moment you master this particular laws, you now solve it from this particular laws, you will not have much problems in cycle geometry 1. This is very simple. This is just Pythagoras. This is just angle at the center is always twice angle at one circumference. This angle in same segments are always equal. Angle being formed by a cycle is 90 degrees, and opposite angles of a cyclic quadrilateral are always for supplementary. They are very simple. So just give it your best, revise, and solve as many questions as possible. you'll be very, very good with all this particular type of what question. Take notes. Always remember, practice makes perfect. They are very, very simple to see. But by the time you start applying them in questions, solving more questions in it, you might be thinking that it's complicated. But the more you practice, the more you get understanding to all these things. So thank you and see you in the next one, insightful